Okay, Periscope is up. Stand by for YouTube. Okay, YouTube is up. We are a go.
Awesome. Now we're going to give maybe one more minute for people that aren't just joining, and then we'll get started. And like always, please put your local time in the chat. We've got people from everywhere. I think even more countries than we had for our last event have applied to HackFS, so it's always cool. Let's see, local time for me, 11 a.m. Let's see who gets the latest local time. (8:30 p.m.) That's what I'm seeing. It's the latest. All right. We are going to get started. Thank you, everybody, for showing up. And like I said, this is a HackFS event leading up to the kickoff next week. The kickoff is Monday at 12 noon Eastern. Hopefully, we can all see you there. Before we get started, just a reminder that if you want to take part in HackFS, you do need to stake. If there are any issues with that, reach out to any ETHGlobal team member. If you don't stake, we will be kind of trimming out the slack just so we have only hackers that are participating over the next few days. Yeah. So today we are starting off with the Solidity and Buidler workshop. If you're not familiar, this is the right place to be. You're going to learn a ton from Patricio. He's the CTO and co-founder of Nomic Labs, and they've been doing a ton of great work, specifically with Buidler. And we're really excited to have him here and sharing some of his expertise. So without further ado, I'll let Patricio take it away. And he needs to be unmuted.
Okay, that's it. I had a problem with Zoom where I couldn't unmute myself. But hi, everyone. Thanks for being here. As Trent said, I'm Patricio from Buenos Aires, Argentina. And this workshop is going to be mostly around how to set up an Ethereum smart contracts developer environment. This is not going to be like a Solidity class. We are not going to go through the different aspects of the language. That would be like pretty boring, at least for me. Like me just here for an hour talking about Solidity syntax. So instead of that, we are gonna follow a tutorial that it's gonna leave you with a ready to work environment. So you can continue your learning by actually writing some smart contracts, test them, and play a bit with the language. For this tutorial, we are gonna assume like basic knowledge about Ethereum. So where a transaction is and how and very basic knowledge about how the network works, like miners and waiting for transactions to be mined, what's a blockchain. But if you are not super confident with those concepts, I think this workshop is still worthy. It won't go very deep into the technicalities of Ethereum. So I guess you can still enjoy most of it. So everything that we are gonna do is actually already on the Buidler site. Its site is Buidler, the typo is intentional, .dev/tutorial. So if you get lost or if you want to go over this again after this workshop, you just come here and everything is written down. I'm gonna be using this as a cheat sheet myself probably. So we are gonna be following this tutorial very closely. So first, I hope that you received a notification or message asking you to set up your environment. So in Buidler is based on Node.js. It's a Node.js command line application. It's common in Ethereum to test your contracts using JavaScript. The reason is that both Ethereum and Solidity are very like domain-specific things. Like you can do lots of things with them, but some of them you can't. So testing your contracts or interacting with them directly with Solidity can be pretty cumbersome, and some things are impossible, like, I don't know, accessing the file system. So that's the reason that we normally develop smart contracts in Solidity, but test them using other languages. And in this case, it's JavaScript, so we use Node.js. But we do require some specific setup for Node.js because some of the dependencies use C or C++, and you will need a C compiler setup. And it takes time. So I hope you did follow this tutorial, this part of the tutorial. But if you don't, you can do it now. But as it takes time, we just gonna advance as if you were already as if your environment was already set up. So sorry, I forgot to share my screen. I just noticed that. This is the tutorial I was talking about. So there's first a general overview, just like an introduction. But this section is this one, setting up your environment. It's gonna tell you how to install Node. And it has like a few extra steps. It's not just like a plain installation of Node. If you use Linux, you are probably good to go. But if you are using Windows, you should check that. But apart from that, once you install everything, this is just a Node.js project. It's like a common JavaScript project. So what we are going to do is set up a Buidler project. And the first thing that you need to do that is just setting up an npm project so you can install Buidler. We are going to start with an empty folder. You can name it whatever you want. I just name it HackFS. And in that folder, you need to initialize an npm project. That's very straightforward. You just have to run npm init. I'm gonna be writing everything myself and doing everything myself. So if you want, you can follow whatever I do, and you are gonna experience this firsthand. So to initialize the project, you just run npm init, and then it's gonna ask you a bunch of questions. We are gonna press enter until it's ready. And after that, we are gonna install Buidler. So you just do it with npm add Nomic labs /Buidler. And this is gonna take some time because it has lots of dependencies. But in the meantime, let me tell you more about what Buidler is. So Buidler is an Ethereum development environment. It comes with a bunch of things. The main of it, or one of the main things, is a task runner. So Buidler automates everything, all your smart contracts development needs, like compiling, testing, and a bunch of extra ones, like deploying your smart contracts to the Ethereum network. But apart from that, Buidler comes with what we call Buidler EVM. It's a development Ethereum network. It's just like the Ethereum network, just like mainnet, but focused on development. And what does this mean? This development network is not like an actual blockchain where money and valuable things are handled. Here we just initialize like a virtual blockchain where you can run your tests, and then that gets discarded. So every time you run Buidler, a new blockchain, like almost an empty one, is going to be initialized for you. You are going to be able to run your test with a bunch of fake Ethereum, like Buidler's EVM money. you are going to use that to pay for gas and things like that. So you don't have to worry about getting ETH to test your contracts. But apart from that, it's also super fast. Testing things on mainnet would be quite slow because you have to wait for transactions to be mined. Here, things are like automatically mined, like instantly mined. So that makes everything much faster. But also Buidler EVM is like developed specifically to create and debug smart contracts. So it has extra functionality to help you debug your smart contracts and understand what's going on when you are executing or deploying a contract. Buidler EVM doesn't just execute your smart contracts, but understands part of Solidity. So it can give you like more contextual data whenever things go wrong. So now that we have already installed Buidler, well, does all of you actually install it? Like, does anyone needs more time? Let me check the chat. Okay, I guess we can continue now. Otherwise, if someone needs more time, feel free to ask for it.
Is everybody good? Just give a thumbs up or a confirmation in the chat. All right, we got a couple people.
Okay.
Yeah, cool.
Okay, so let's keep going. By the way, these things that I'm currently explaining are in part 3 of the tutorial. So if you get lost or maybe you have just joined, you can come here, follow these things, and you are gonna get to the same point. So now let's run Buidler for the first time. To do it, you have to run npx Buidler. npx is nothing Buidler related. It's just a Node.js utility that it's similar to sudo, but instead of telling the system run this as a super user or root, it means run my local version of Buidler, the one that we just installed. Because if we were just doing like Buidler like this, it would be a global installation, but that's not what we want. So if we run npx Buidler, we are gonna see this like welcome screen. It's gonna have a bunch of options, but we are gonna use the second one, creating an empty Buidler config, because we are gonna show how to set up the entire thing. We don't want to use the sample project here. Oops, so that's it. We have an empty Buidler config now, and it's actually empty. It's just like a JavaScript file. It exports an object, but it's empty. Buidler works without any specific configuration, but it does have a plugin-based architecture. So if you just install Buidler, you are gonna get a few things, but those things are just like the very basic functionality that plugins use to offer like more advanced or more useful things. Buidler by default has this task runner and Buidler EVM, but if we weren't to use anything else, using Ethereum will be pretty cumbersome. So we are going to use a library to connect to Ethereum that it's called Ether.js. It's very popular, and it's what we recommend to use Ethereum, to use JavaScript and Ethereum. And apart from that, we are also going to be using Waffle, that it's a testing library that it's very handy to test your smart contracts. So we need to install those plugins. And again, we can come to the tutorial, and by following it, you are going to arrive to the same part where you have to install your plugins. So we are just going to copy and paste this npm install from here and run it. This is also going to take some time. It's going to install the plugins and the libraries that they use. So let's wait for it. So Waffle is, we are going to be using Waffle mostly to add extra functionality that is useful for testing. And ethers, it's like the thing that we are going to use to interact with Ethereum. Okay, this is gonna take maybe a minute. I'm gonna wait for it to finish before continue, I guess. Does anyone has any question right now?
Have you talked a little bit about like the background of Buidler and how you guys came on the idea, or like what it's typically used for while we're waiting?
Yeah, sure. So Buidler currently is being used like pretty much. It's getting a lot of traction around the DeFi ecosystem. Like many DeFi projects use Buidler to test, to build their smart contracts, but specifically or mostly for testing them. Like the most the most useful features of Buidler are around debugging smart contracts, because the issue is that as you run your tests in Ethereum while you write them with JavaScript, you are like executing two different VMs at the same time. And it can be very hard to understand what's going on in Ethereum. Like on JavaScript, you have lots of functionality of things and infrastructure built around it to aid programmers during their development. But Ethereum is a much newer platform, and it's a special platform in this way that things get to run on the blockchain. There's the EVM. It's pretty new. It's quite different compared to other VMs, and there's not lots of development tools. There's a bunch of them like Buidler, but everything is new in this environment. Like Ethereum didn't exist 5 years ago. So what we mostly work on Buidler is like closing that gap between the JavaScript development experience and the Ethereum one, like adding functionality to Ethereum that people are used to use on JavaScript, like console log or Solidity stack traces. Like before Buidler, you weren't able to print messages from your smart contracts. And with Buidler, you just import the library and use console logs just like in JavaScript. We are going to see this like in a few minutes. So does anyone need more time to install the plugins? This is probably the last thing that we need to install. So this is going to be the last big post. Then we can actually start. I think there's something in the chat. Okay, someone is asking, what's the advantage of using Buidler over web-based IDEs such as Remix? I think the main advantage is that you can use the tools that you normally use for other languages. Like if you're used to use Visual Studio Code, you can use it. But if you're a Vim fan, or VIM maybe, you can also use that. It's like a normal environment, whereas a web-based one, it's like kind of rigid and limited, and you lose access to most of your tools. Okay, so let's continue. Now we are gonna create our first contract. To do that, we need to create a contracts directory. This is where we are gonna place our Solidity files. Oops, I forgot about this part. So we already installed the plugin, but we have to tell Buidler that it has to use it. And we do this by calling this use plugin function that it's already available. And the name of the plugin. Here we are telling Buidler in its config file that it has to use the plugin Nomic Labs Buidler Waffle. Apart from that, we are just gonna set a version of Solidity that is the one that we are gonna be working with. This is not strictly necessary, but we recommend doing that to be sure about which version of Solidity you are using. Okay, so now we have our config ready. That's all we need. And we can create our first Solidity file. So in this tutorial, we are going to be creating a simple token. It's not going to be a standard compliant token, but just like a very simple one for educational purposes. We have to create a Solidity file to place our token. So let's do that. And let's call it token.sol. We can use whichever name we want, but I think keeping the same names for files and contacts is useful. It's like easier to find things if you do that. And every Solidity file has to start with this pragma thing. It's just pragma space Solidity and like a version identifier of Solidity, like which versions of Solidity can compile this file. Here we are telling the compiler that every 0.6 point something version is fine. This is also pretty common on Node, on NPM. So I guess most of you can recognize this. And then we are ready to create our contract. So to do that, we use this contract keyword, and it just takes the name of the contract. It's pretty much like a class in JavaScript, C, Java, or everywhere. And that's it. Here, this is our first contract. We can compile it, we can deploy it, and it won't do anything. So it's pretty boring. So let's add a name to this contract. And that would be just like a public variable that other contacts and applications can access. So we do it by declaring it just like in any language. Oops, public name. And let's call this my token. And that's it. So here, what we are doing is declaring a storage variable. So in Solidity or in Ethereum, you have both memory-based variables and storage-based ones. Like memory-based are normal variables, like the ones you use in any programming language. But storage ones get saved in the storage. So you can access them through different transactions. That's what, like, it's similar to the file system in a normal computing environment. These values don't get lost, and you can access them whenever you want and modify them. So that's what we are going to be working with. But first, let's deploy this token contract and test that our name is actually my token. So we can do that by creating a folder called test. That's a common name of JavaScript to play your test files. And test files are actually just JavaScript files. They don't necessarily have to do anything with Ethereum. Oops, something weird is going on. And Buidler will just find these JavaScript files placed on the test folder and run them. It's gonna run them with Mocha, which is a super popular test runner for JavaScript. I guess many of you already know about Mocha, but because it's not Ethereum related, it's common to use Mocha for anything JavaScript related. And the way you use it, it's by declaring blocks of functionality of related tests that are going to test like a part of the functionality of your program. So here, for example, we are going to test the my token contract, and we do that by telling Mocha with this describe function that you are gonna declare a bunch of tests that are related to my contract. This is just the title. It doesn't mean anything special. And then inside this callback that you pass to the describe function, you can define your tests. And you do that by calling it, which is a function to declare tests. And the idea is to do things like it should have the correct name, and then pass it a callback that actually verifies that assumption. Oops. So here we can test our things, but for now, let's just print something. So does anyone have a question? Sorry if this is kind of boring for now, because this is just plain JavaScript things, but we need to explain a bit of it. Is there any question on the chat?
Just one small question. Why do we need the async keywords in front of the function?
Async? Okay, that's a good question. So in JavaScript, there are two kinds of functions. Common ones, or I don't know, non-async ones, are just functions like in any language. But you sometimes have to do things that can be restored immediately, like I don't know, doing an HTTP request or connecting to the Ethereum network and sending a transaction. Those things take some time, and JavaScript doesn't block and wait for them to complete. It just continues executing, and you do that with async functions. An async function, instead of returning a value, like if I do return 123 here, it's gonna return an object called a promise. This promise encapsulates these asynchronous operations in a simple interface that JavaScript knows how to handle. So if I were to call an async function and I do want to wait for it to complete, I just do await, I know, func. Oops. So if this function were async, the await keyword forces JavaScript to wait for its promise to complete. And as Ethereum is like a network that you are going to connect and send requests to, most of the things are async. So we are going to be using this await keyword and async functions a lot. So thanks for asking that. So let's keep going and run this test. So how do you do that? You just run npx Buidler test. And as I mentioned before, it's gonna run all your JavaScript test files one by one. And first, it's gonna compile your smart contract. It will only compile it the first time you run it. And of course, whenever you modify it. So this one, oh, yeah. So this is a new Solidity thing. So the first thing that you have to do is declare your license. We don't have a license right now. So let's just copy and paste that thing from the warning. It's unlicensed. That's what it means. But here, after the compilation, the tests are run. So it's gonna first run our describe block, my token contract. So you can see it here. And then the different tests that belong to that describe block. Here we only have this one, should have the correct name, and it displays hi. And this is what it's going on here. It just displays hi. So is everyone following? Like, should I continue? Does anyone need more time? Or does anyone have a question now? Let me check the chat. So Keshav asked about how is Buidler different from Truffle? Buidler and Truffle are very similar. The main difference is that Buidler has a plugin-based architecture that lets you combine different tools. So for example, Truffle doesn't use Ethers, the library that I mentioned before, and you can't use it with Truffle like easily. It uses another library that it's called Web3.js. But in Buidler, you just get to choose what to use. You can use Ethers or you can use Web3 or both of them at the same time. You just install the plugin and those libraries get automatically set up for you and they are ready to be used. And this is pretty nice because that way you can choose whichever environment you feel comfortable with. And it also encourages people to build their own plugins, to customize their own things, or even publish plugins for other users to use. Okay, so now let's actually test our token. So to do that, we first have to somehow get the token contract here. We are gonna be using Ethers for that. And Ethers have this concept of contract factory. It's like pretty similar to a class. So you do have contract factories and you have instances of the contracts, like you have a class and you have objects. So the first thing that we are gonna do is use Ethers to get the contract factory of token. So here we pass the class name, the contract name. It's the same as the file, of the contract file name and the test file name. I think that's easier, so you don't have to be thinking all the time which name to use. And as I mentioned, most things are async. So here we are going to be using this await keyword for to wait for that async operation to finish. And we are gonna store this on a token variable. Okay, so now we get this contract function. What we can do is deploy our token. And to do that, we just have to call a deploy function that contract factory have. And this is also an async operation. You have to send a request to the network. So we have to await for it. Oops. Okay, so what this deploy function does is creating a transaction and signing it and sending it to the Ethereum network. In this case, the Ethereum network is Buidler VM, and it's gonna be mined instantly, but that's not always the case. So you have to wait for transactions to be mined, and you do this by awaiting for this deployed function that's gonna return a promise which will be resolved already right after the transaction gets mined. So, oops, something weird is going on with Zoom. So after it gets deployed, we can check, for example, its address by, I don't know, by doing a console log here. Let's do that. Oops. Let's see, ethers get contract factory. It's not a function. Let's check in the tutorial. Maybe I have a typo or something like that. I guess it would be this section, section 5. So it's ethers get contact factory. That's weird. I have the same name. Let's see. Nomic Labs, Buidler, Waffle. Let's check this. Sorry about this. I followed this tutorial like minutes before starting. Oh no, it didn't. Let's see. Here I'm just printing the ethers object to check if that function.
That means it's deployed. So I do have a question about the wallet when you get a chance, like where it's getting that. Is that included as part of the internal builder EVM that it stands up? Is that where it's like a magic wallet?
So can you repeat?
Yeah, where's it getting a wallet from, right? Where's it getting a wallet inside the transaction? Is it just built into the framework that it just magically does it behind the scenes?
Yeah, so Buidler EVM has a bunch of accounts by default. I think it's like 20 accounts or something like that. Those are like unlocked and you are free to use them. It will sign your transactions by default with the first account. And those also have like, I don't know, a lot of ETH, like maybe, I don't know, a lot. It's fake ETH. It's just like Buidler EVM ETH. And you use it like to pay gas. So in a normal network, like in mainnet, you should make sure that you have funds to pay for your gas for the transaction. So this token.deploy may be spending, I don't know, 100K gas, and that may cost money. I mean, that does cost money. I don't know how much, but you need to fund your account before deploying a contract. But here in Buidler, as it's designed for testing and development, you don't need to do that. It's already set up for you. So that's why it's nice to have like these plugins that let you integrate tools automatically, because those kind of things are already taken care of. You don't have to be worrying about, okay, I have to set up my environment like this or like that. You just install a bunch of plugins and you're good to go. Okay, let's check this. Nomic Labs, Buidler, Waffle. This is super strange.
I think you need to require it explicitly.
It's the refi API of Ethers.js. The tutorial uses Ethers.js before.
Really?
In your test file, if you scroll up.
Yeah, I mean, I can, something that I didn't mention is that here, when I use ethers from the global environment, that's just for convenience. Like Buidler injects a bunch of things to the global environment, but I can import it explicitly. I can do that like this, like requiring Nomic Labs Buidler, ethers. And that's the same as using it globally. Like I get the same instance of ethers. But yeah, as Franco said, I probably have an issue with my version of Ethers with respect. I mean, it might have changed a bit from the time we published that tutorial. It's weird because I followed it. Let's try again. Oops. Okay, I know what's going on. So Visual Studio Code inserted this import directly, automatically, and I haven't noticed that. So yeah, I was importing another version of Ethers that doesn't have this function because it's a helper added by Buidler. And it couldn't find it, so my test was crashing. It should work now. Okay, that's it. Sorry about that. I should have scrolled my file. My file. So let's just use it from the global environment, just to keep things as close as the tutorial as possible. So to recap what we've done so far, we created a token that it's a contract that only has a public variable called name with a constant value. And what we are doing here is getting the contract factory token, deploying it, waiting for the transaction to be mined. In this case, this is instantly, and then console login its token, its address. But what we actually want to do here is to check that the name is correct. And the name is a public function in Solidity. Public means that other contacts can call it, but also that programs outside of the blockchain can access that function. And in Ethers, you do that by just treating like your token here, which is a JavaScript object, as if it were your actual contact. So if there is a public function here, you are going to have it also in JavaScript here. So you call name, and you are going to get the name. It's just a getter. The only difference is that this is also an async operation because it has to call the EVM. It has to not send a transaction, but do a call, like telling the network, okay, give me the value of this getter. And we can also print this, and it should say my token. Okay, so that's fine. Like the contract is doing what we expected. But like testing like this, checking all the time the values manually, it's gonna be very error prone. So as in any programming language, we are gonna use assertions here to test that the values we get actually match what we expect and do that programmatically. In this case, we are going to use Chai. That it's a super popular library, especially when using Mocha, that has a bunch of assertion functions that they are just like handy functions to test things. So we are going to import Chai by doing this, require Chai. Chai has like a bunch of different APIs. We are going to be using one that it's called expect, and expect works like this. You just call it with a value, and it's going to wrap it, and it's going to return an object that has lots of functions that let you test what you want. So here we are going to be calling expect, passing the name that we get from the network, and calling to be equal. And here you're gonna put my token. And let's try this out. Okay, so the test passed. There's nothing to show. Mocha is only gonna show things if your test failed. But we are fine. But let's first try how failing tests are displayed. So here I changed the expected name. So as I'm getting my token 2, it's gonna fail. Okay, so this is it. You can see your test in red. That means that it failed. Here you have a summary of the amount of tests that failed and the amount of passed tests. And here there is like a further explanation on how it failed. In this case, it says that you were expecting my token to equal my token 2. The expected one is in green, my token 2, but you got my token. And that's it. So let's continue. So now that we know how to write very simple smart contract tests, let's add some functionality to our token. For example, we can add a symbol that it can be, I don't know, empty, and it's just another variable. We are not gonna be testing this because it's kind of boring, but I guess you get it. Does anyone have any questions so far? Let me check the chat. Okay, so let's keep going with building this token. So the main thing that the token does is just keeping track of balances, like how much money or tokens does any account or person has. So to do that, we are gonna use a mapping. That it's a data structure that it's already built in into Solidity. A mapping is just like a hash table. It stores values associated to a key, and you declare it like this: mapping and the type of the key and the type of the value. And in this case, our value is going to be a uint, and our keys are going to be addresses, because an address is like an identifier of an Ethereum account. And then its name, balances. Okay, so this is not going to be a public variable. It's going to be private. We don't have to add like a private keyword. That's automatic. And this is going to be stored also on storage. So we are not going to be losing the values between transactions. We want that to be recorded on the blockchain like forever. And to access a private variable, you need to define some kind of getter. So let's do that. We are gonna define a function called balance of, which receives an address, I don't know, owner, and returns a uint. Here, first you have to define its visibility. And then we are gonna declare this function as a view function. View here means that it can read the state, like the storage, but it can't modify it. And the cool thing about view functions is that you don't need to send the transaction to execute it. You just can tell your node to run a certain view function and give you the return value. And this is nice because first, it's automatic, as you don't need to send it instant, I mean. As you don't need to send a transaction, you don't have to wait for anything to be mined. You can get the return value almost immediately. And also it's free because you don't have to pay gas as there's no transaction. And oops. And now we have to declare its return type. And you do it like that. So then implementing this is pretty easy. It's just like returning the balance of the owner. And that's it. That's our balance of function. So let's test this. So let's create another test. It should return the right balance. This is also an async function. Tests are normally async, while the scribes are not async. And here we have to do the same thing, right? Like we are gonna deploy a token. We are then gonna call balance of and compare the result of calling it. So here, instead of name, we are gonna use balance of and pass it an address. Let's use the address 0. It has like 40 characters or something like that. Let's do this. There's a constant on ethers that I never remember its name, so I always do this. Oops, wait. How many? That's 28. Oops, sorry, Zoom is doing something weird. Okay, so here I have the other 0, and let's compare its value to 0, because that's what we should be getting. Okay, it passed. So by default, mappings are always initialized in 0. So that's fine, because everything should have 0 balance until someone sends them money. But before we continue, let's refactor this a bit. Like this token deployment thing, it's getting a bit repetitive. So there is a way to do this in Mocha. So you can declare something similar to it, that it's called before each, and pass it an async function. This function is going to be executed before running each test. So if something gets repetitive, you can do it here. But what we do need to do is, instead of using a local variable here for token, we need to declare it outside that function, so other functions can access it. Okay, let's run this again. Okay, cool. So now let's add a function to transfer tokens. That's also very straightforward. It should look something like this: transfer the receiver and the amount of tokens. It should also be public. In this case, this is not a view function because it's going to modify the state of the contract, and it doesn't return anything. So that's it. We don't pass the sender of tokens here because that's going to be the one who sends the transaction. You can access that account by doing message.sender. So we don't need that param. But there is a problem. So the way I would test the thing is by actually doing a transfer and seeing that it was successful. But if we don't have any token, I mean, everyone has 0 tokens. Who is going to be the one that transfers this value? So what we need to do is to initialize this contract with an initial supply of tokens. There's a bunch of ways of doing this thing, but we are going to go for the simplest possibility. So what we are going to do is implement a constructor function that's going to be executed when we deploy our contract. And in that constructor function, we are just going to assign a bunch of tokens to whoever deploys this contract. And we do it this way. Constructors have always this name. It has to be public. Otherwise, we won't be able to deploy this contract. And we are just going to initialize the balances mapping and add some value here. I know it's something. Does anyone have any questions so far? Let's check the chat. Okay, so before testing transfer, let's actually test that the constructor is initializing this correctly. Otherwise, we are going to have a hard time. So should initialize the balance. And here, what we need to do is just call balance of and test that it's 1K. But the problem is that we need to know who sent the deployment transaction here. Otherwise, we won't have access to its address. And we need it to check its balance. So what we can do is use Ethers again to get those Buidler EVM accounts that I talked about like a few minutes ago. But as I mentioned, Buidler EVM has a bunch of accounts automatically initialized and funded for you. And transactions by default are sent with the first of those accounts. So what we are going to do is get those accounts and store the first one in a variable and use it to complete this test. So let's do it here in the before each, because I suspect that we are going to be using this thing a bunch of times. So let's do this. Let's get the accounts. We can also use an Ethers helper here. Okay, this is gonna happen all the time, I guess. So here I have the accounts, but I am only interested in the first one, and I want to store it somewhere. Okay. So now that I have the account that it's deploying the contract, I can use its address. This is also async. And I guess this test should be completed now. We are checking that the balance of the account that actually deployed the contract is initialized correctly. Let's try it out. Okay, cool. So now that we have that account and that we have an initial supply of tokens, we can actually test the transfer function. Okay, so what we are going to do here is transfer some tokens. Let's use this same account, like 0. I'll declare a const just not to repeat those zeros. Okay, let's transfer some tokens from the sender account, that it's the same one that deploy the contract, to the zero account, and let's check the balance. First, you need to pass the receiver and then the amount, 0 and 1. This is going to send the transaction, so it's async. And once we await it, we can check the balance of the account 0 and also check the balance of the sender, because it should have been decreased by 1. So let's do this. And the one of sender should be 999. Okay, let's try this out. Oops, expected 0 to be equal to 1. Oh, yeah. So I never implemented it. So it's fine that it was failing. Okay, what we are going to do is just subtract some balance from the sender and add it to the receiver. Balances. Amount. And then we add it to the receiver. And that's it. Now I guess the test should pass. It's gonna recompile everything. Okay, now it's passing. So this is like a very basic implementation, but it does have some problems. So let's try a few things, like, I don't know, let's transfer 2,000 tokens, like more than we actually have, and let's see what happens. I'm not gonna change this because I'm not even sure what it should say, like 2,000, what 1,000, maybe here 0, I don't know. Let's try it. Okay, expected 2,000 to equal 1,000. Okay, that's already pretty weird because we never created 2,000 tokens, but the balance of here it's 2,000. So here's where Buidler comes very handy. If you were to debug this by just calling getters here or sending transactions, you are not gonna have a very good time. It's very like you are only gonna be able to debug the contract from an outside perspective, and getting to the internal execution, it's not very easy without Buidler. But here we can use a console log library that we created. You do that by just importing Nomic labs / console dot sol. It's Nomic labs / Buidler / console dot sol. That's a Solidity library. It's implemented in a very non-intuitive way, but you don't need to read its source code. But it's just a bunch of Solidity that declares a console, and you can call it like if it were JavaScript, like transferring from something to something, and let's do this. And now when I run my test, it's gonna print that console log whenever that function executes, just like if it were console log from JavaScript. And this is very handy to debug your things. So here we get to know that we are transferring from the sender account, it happens to be this one, to 0. But the problem is that we are transferring more tokens that we have. So maybe we can do things like transferring some amount of tokens, and we have amount. So here it's something like balances, message.sender, amount. And let's see what happens. Oops. Okay, so transferring 1,000 tokens, and we have 2,000. Okay, that's weird. I mean, that shouldn't be happening, but we can prevent people from actually trying to do things like that. I mean, if it works, you are creating money out of nothing. So there's always going to be someone trying to do that. So the actual thing that we want is for the amount to be less than or equal the balance. And we can verify if this is true here by doing a console log here. It should probably print false. Right, so this is the problem. So this like requirement of this function is being violated by the code that we are trying to run. And of course, it's gonna screw our code. So what we want to do is to protect our smart contract from this kind of things. And we can do this with a Solidity function called require, that it receives a Boolean expression and a message that it's going to be printed, that it's going to be used if this Boolean expression is false. So in this case, what we want to require is that the amount is less or equal to the balance, and we can add a message here, like not enough funds. And this message is going to be used to make the transaction fail, but fail with a specific message. This is optional. You can do just this, but I don't recommend that because then debugging is a mess if you don't know why your transactions are failing. So here, if we rerun our test, this will evaluate to false, and this require will make the transaction fail. Okay, so here it failed. It failed with a message telling you that the transaction reverted, and here is the message that we added to the require here. And the cool thing about Buidler is that it's gonna see that your transaction failed and recreate a Solidity stack trace. So instead of just getting the message of the require that failed, you are gonna also have a stack trace of Solidity of the contract that you are executing. In this case, the stack trace is very it's tiny because you are failing on the same transaction on the same function that you are calling. But if you were to fail on other transactions on other functions, it will be present here, like in any stack trace from any other language. So this is very handy to debug your transactions. So having console log and stack traces, you have like a debugging experience very similar to any other language. So finally, what we are gonna test is that this require actually does what we want it to do. So what we can do is use Waffle here. As I mentioned, Waffle is a testing library for smart contracts that adds some functionality to Chai that it's very useful to test smart contracts, especially when they fail. There is a helper that it adds to Chai that I don't remember its name, so I'm trying to find it here. Okay, yeah. So instead of using to equal here, we are going to be using reverted with and passing it the message, not that we expect the transaction to fail with. And instead of awaiting here, we have to await for the expect to be resolved. I think I modified the wrong test. So sorry about this. Okay, it's here. Expect the token transfer to be reverted with not enough funds. And let's try if this actually works. Okay, cool. So that's it. The good thing about testing for revert reasons or revert messages is that you actually get to know that your transaction is failing for the reasons that you are think that it's failing. Because you can also do this and test without the message, but maybe your transaction is failing because of something else. And in that case, your test will be kind of lying to you. And maybe you modify your contract a bit and your require stops working. So we strongly recommend using revert messages in your tests. So I think that's pretty much it about how to develop, test, and debug contracts using Buidler. You can get to the tutorial, complete your token. Like here, we actually implement much more functionality, I think. Or for sure, we do implement like a complete test suite for this contract. There's a bunch more things. Maybe, I don't know how much time left we have. Maybe Trent.
Yeah, if you've got a little bit more content, I think we're going to cut off in maybe 10 or so minutes. So if you want to keep going for that much time, that should be
okay. Okay, so let's first see if someone has any question. You can use the raise your hand functionality if you want to ask anything, or you can also ask in the chat. Okay, so let me show you how to send transactions from other accounts. Like this is also very useful for testing. For example, here we are always deploying and sending transactions from the first account, like that we call sender here. But there's also other accounts, and we should probably test doing things with them. Let's call this other, I don't know. So account other. What we are going to do is transferring some tokens instead of from the sender from this other account. It's pretty straightforward to do that with ethers. You just have to call the function on the token, on the contract that you are going to be using. It's called connect, and passing the account here. So in this case, we are transferring, I don't know, 1 token from the account other to the 0 account, and it's gonna fail in the same way because we don't have any token in the other account, and that's fine. The same test passed, but let's see if it actually works. And to do that, let's transfer some money to the account other from the sender. So I know 100 tokens, and we are just gonna be calling the contact functions to do this. Like in this kind of tests, you do use JavaScript, but you have to think of this as if you were actually executing the token that is written in Solidity. So if you want to add some balance to an account in order to test something with it, you just transfer it some tokens. Like there's nothing special of it being in Solidity or a contract. It's just like an object. And let's call transfer to other, but not from other. So let's delete this here. And in this case, this expect should fail, because now that we have 100 tokens in the other account, this transfer from other to 0 should pass. Okay, that failed, but from another reason. It's good that we were checking the reason why it failed. So it says argument name option. Okay, I think the problem is that here we are passing the account's object and not its address. Like in everywhere else, we are going to use the getAddress function to get the address. So let me explain a bit about what's going on here. Addresses in Ethereum are just like 20 bytes of data, and there's a bunch of ways to represent them. Normally, we use hex encoded strings like this address. This is like the most common representation of an account with a string of its address. But in Ethers, there's an object that represents accounts. It's called a signer. And a signer does have an address, but has a bunch of other things like, I don't know, other.get balance. And this is gonna return the amount of ETH that this account has. So when we call transfer here, passing the other object instead of the address, it failed because it wasn't expected that type. Okay, cool. So now the test failed, but for the reasons that we were expecting, this transaction is not being reverted. It's actually working correctly. And what we should do is probably remove this and just maybe check that the account 0 does actually have a token after this. Okay, cool. So it's passing. And I think that's pretty much it, what you are going to be using to debug and test your smart contracts. There's also something else that you want to do when developing smart contracts, that is deploying them to a live network. We don't have enough time to cover this here, but there is a section on the tutorial explaining how you can do that. Basically, you have to create a script that it's going to be run with Buidler, and it's going to do pretty much the same than we were doing here, like getting a contact factory, deploying it, are waiting for the token to be deployed, and then it prints its address. But apart from that, there is a bunch of other plugins that you may want to take a look at. And there's one that it's specifically for deploying contracts. It's called Buidler Deploy. It's built by one of our community members, and you can learn how to use it here if you want to automate your deployments a bit further. There's a lot to tell about this plugin, and we don't have enough time, but you can find it if you go to buidler.dev and go to the plugin section here. And I think that's pretty much everything. Does anyone have a question? Thanks.
Yeah, that was really great. Glad we had a little bit of extra time to go over a little bit more content. I think we're going to wrap here. We went a little bit over time. I hope that's all right. Some really good stuff. Again, thank you, Patricio and Franco was doing a little behind the scenes chat support, so that's always good. If you missed anything, remember this is recorded and will be available on the ETHGlobal YouTube channel just after this ends. A few logistical things. Again, remember we have 3 more events. One tonight at 4 p.m. Eastern. That's a Filecoin, getting started with Filecoin. We already have I think around 67 people registered, so it's going to be a good event with Andrew Hill of Textile. And then tomorrow there's a libp2p session and decentralized messaging with Jacob Hune of Filecoin, and then another brainstorm session in the evening, Eastern time, 8 p.m. with Juan. That one's going to be a little bit more open-ended. You can show up. We're going to chat about ideas. We're going to be pulling from the 100 hackathon ideas sheet that you may have seen floating around. So yeah, that one's going to be a lot of fun. And then the other 2 sessions tonight and tomorrow morning will also be, I'm assuming they're going to be as high quality as the ones we've already had. So those are the 3 that are happening tonight and tomorrow. There is the kickoff, as I mentioned at the beginning of the session. That's Monday, 12 noon Eastern. Again, it's going to be sort of setting the stage for the next 30 days. I hope everybody attends. We'll be sending out invitations for that as well. Thank you so much, Patricio. Again, it's a huge help. We appreciate you sharing. Yeah, give him a little claps. This is super. Yeah, I think that's it. I don't think I missed anything. Oh, make sure to stake. I mentioned this at the beginning as well, but you have to stake. You get it back at the end of the event, but we want to make sure that people that we're supporting are committed to participating fully. I think that's it. I'll let everybody have a good rest of the day. Thank you again, and we'll see you.